Atlantis Rising Research Group, audiobooks. From Atlantis Rising Magazine number 122. Mega Engineering in the Stars? By Dr. Robert Schoch. Over 1,000 years ago, while European civilization stagnated during the Dark Ages, did a race of advanced extraterrestrials in a distant part of our galaxy build a huge energy-capturing megastructure around their sun? This may be the story behind an anomalous star known to astronomers as KIC 8,462,852, KIC equals Kepler Input Catalog of the Kepler Space Observatory. Informally dubbed Tabby Star, Boyajian Star, Tabetha S. Boyajian spearheaded initial analyses of the star, and WTF Star, after the title of the paper authored by Boyajian, et al., 2015, revised 2016, Planet Hunters X. KIC 84, where's the Flux? R14, this mysterious object continues to elude a satisfactory and wholly convincing natural explanation. Launched in March 2009, the Kepler Space Observatory was designed to survey the Milky Way, searching for exoplanets, planets orbiting around stars other than our Sun. Despite some setbacks, Kepler has been extraordinarily successful in its mission. Thousands of exoplanets have been discovered. Extrapolating from the data thus far, possibly our Milky Way Galaxy contains tens of billions of Earth-sized planets orbiting stars within habitable zones. The primary method of detecting such exoplanets is by the periodic dimming of a star as an orbiting exoplanet crosses in front, blocking light. Kepler can continuously monitor approximately 150,000 stars. This brings us to the strangeness of KIC 84. KIC 84 has dimmed and then brightened again on numerous occasions, but not in the systematic way that a star typically dims due to an orbiting planet or planets. The dimming, the dips in brightness detected coming from KIC 84, occur in a manner that appears random. For instance, after hundreds of days of relative stability, the star dimmed by 15% over several days. Then, after having come back to approximately its original brightness, about 725 or so days later, the star suddenly dimmed by 22% over just a few days, subsequently returning to its previous brightness. 3 weeks later, it dimmed by 3% or so. After returning to its previous brightness, not quite a month later it dimmed by 8% for a few days, only to return to its previous brightness once again. To put these levels of dimming into perspective, if our Sun were being observed by an observatory on a distant planet, as Jupiter crossed, the dimming effect would only amount to about 1%. Citizen scientists participating in the Planet Hunters project discovered KIC 84 collectively. These volunteers sifted through data from Kepler looking for patterns potentially indicative of planets orbiting stars, as well as other interesting or unusual phenomena. Tabetha Boyajian, then a postdoc researcher at Yale University, currently on the faculty of Louisiana State University, was overseeing the Planet Hunters when various participants noticed the strangeness of KIC 84. Boyajian became the lead author, along with 48 co-authors, on the initial paper that brought KIC 84 to the attention of the general astronomical community and to the world at large. Other than its odd behavior, KIC 84 is not a remarkable star. In fact, it is a rather ordinary F-type main sequence star. Our Sun is a G-type main sequence star. Stars are classified based on factors such as surface temperature. F-type stars are slightly hotter than G-type stars. Located in the region of the constellation Cygnus at a distance of around 1,200 to 1,500 light-years from us, estimates vary. KIC 84 has an apparent magnitude of about 11 or 12, far too dim to be seen with the naked eye, an estimated radius of 1.6 times that of our Sun and a mass of about 1.4 times that of our Sun. Once brought to the awareness of the scientific community, other astronomers began studying KIC 84 from different perspectives. Although KIC 84 cannot be seen with the naked eye, it has been viewed through telescopes and photographed since the late 19th century. Analyzing old records and photographic plates, Bradley Schaefer, Louisiana State University, determined that it had dimmed by about 20% in overall brightness during the century from 1890 to 1989. But could this incredibly strange dimming be nothing more than an artifact of the diverse instrumentation used to photograph the star? Despite Schaefer's careful work, there were doubts. However, using Kepler Space Observatory data collected from 2009 to 2013, Benjamin Monte, California Institute of Technology and the Harvard-Smithsonian Center for Astrophysics, and Joshua Simon, observatories of the Carnegie Institution of Washington, found that KIC 84 had dimmed by about 3% overall during this period, with 2% to 2.5% of the dimming occurring during an approximately 200-day stretch. This bolsters Schaefer's conclusion that the star dimmed by about 20% overall in a century. There seems to be no doubt that there is indeed something very mysterious about KIC 84. What could explain these strange observations? A number of hypotheses have been put forward. C. J. T. Wright and S. Sigurdsson, 2016, Families of Plausible Solutions to the Puzzle of Boyajian Star, are 14, but none of them are completely convincing or satisfying, at least not to everyone. One possibility suggested to explain the strangeness of KIC 84 is that there are dust clouds or dense regions in the interstellar medium, which occasionally block and obscure KIC 84 from our sight. However, other stars in the vicinity of KIC 84, as seen along our line of sight from Earth, do not show the same strange behavior. Is a hypothetical dust cloud so small that its effects only extend to KIC 84? This seems highly unlikely. Another possibility is that some sort of large disk-shaped dark object, one that blocks and/or absorbs light, with ring structures around it is associated with KIC 84, and as they orbit around one another the light we see from KIC 84 dims intermittently. Such an object might be a black hole encircled by rings of dark matter. Perhaps KIC 84 is part of a binary system consisting of a typical star and a black hole. However, if a star and a dark object formed a binary system, one would expect regular patterns in the behaviors observed, not dissimilar to the regularities of planets orbiting a star. Arguing against this hypothesis is both the apparent lack of periodicity in the dimming dips and also the pattern of overall dimming, extending over a century, of KIC 84. Might the strange behavior of KIC 84 be due to anomalous internal stellar dynamics? Perhaps it is an unstable star that is going through some sort of weird disequilibrium and decay. If so, this would be very unusual indeed, since other than the strange dimming events and decay in brightness overall, KIC 84 appears to be a typical F-type star. Or possibly the odd behavior is due to some sort of merger between the star and another object, such as another star or a black hole. But such an event would generally be expected to result in episodes of brightening, not dimming, unless one argues that the dips in brightness reflect the star's inherent brightness, that is, the star is undergoing sustained periods of brightness, and the dimming is just a return to its background brightness. But, such an explanation appears to be very contrived and does not easily explain the sudden dips in brightness actually observed. Or could KIC 84 be a star in its infancy that is still coalescing and stabilizing, and its odd dips in brightness are due to its youth? This idea has been proposed, but the actual data supporting that it is a typical F-type star in middle age and lacks material coalescing around it, as expected of a young star, and the area where it is located, far from any stellar nursery, argue against this hypothesis. It is also unclear how youthfulness on the part of KIC 84 would specifically explain the strange dimming phenomena. Could some sort of massive collision between planets or planet-like objects, or an exploding planet, have created a debris field that is circling the star, perhaps irregularly, creating the dips in brightness? If such a scenario were true, the fragments, dust, and debris resulting from the collision or explosion should be relatively hot and give off excess energy in the infrared range detectable by space-based telescopes run by NASA. Despite searches, no such excessive infrared emissions have been found associated with KIC 84, effectively ruling out the collision and exploding planet hypotheses, unless perhaps the collision or explosion happened a very long time ago, such that the debris is now cold. This leads us to another hypothesis. In some circles, the favorite explanation for the strange behavior of KIC 84 is that proposed by Boyajian and co-authors in their original paper, that comets or planetesimal fragments either surround the star or are passing by the star. Unlike a massive collision or explosion, comets or planetesimal fragments would be relatively cold and thus not give off excess infrared emissions. However, there are other significant problems with the comet planetesimal swarm hypothesis. It is difficult to fathom how a comet swarm, or similar cold debris, could be large enough to obscure the star by up to 22%, but for only short periods. The real downfall of the comet theory may be this: how can a comet swarm explain the long-term, recorded in a century worth of data, dimming trend of KIC 84? According to most researchers, it cannot. The comet swarm theory is effectively ruled out. So where does this leave us? Perhaps with the most interesting suggestion of all. The hypothesis that brought KIC 84 to the attention of the public is that perhaps the strange behavior could be the result of alien technology. Might KIC 84 be evidence of an advanced extraterrestrial civilization? Possibly it is an example of so-called star lifting, the massive extraction of matter and/or energy from a star by technologically sophisticated beings. In his 1937 novel, Star Maker, British author and philosopher Olaf Stapledon introduced the concept that an advanced alien civilization, in its quest to utilize ever more energy, could enclose or encapsulate a star with a huge material structure, shell or sphere, in order to capture and utilize energy emitted by the star. Stapledon's idea was fictional, but in 1960 the English-American physicist and mathematician Freeman Dyson proposed the idea in the prestigious journal Science, June 3, 1960. Thus, this concept is now often referred to as a Dyson sphere or some variation on the theme, such as a Dyson ring for a series of objects orbiting along the same path around a star, or a Dyson swarm for a large number of independent constructions, perhaps energy collectors and artificial habitats, forming a dense collection around a star. In a follow-up to his initial article, Dyson clarified his thinking: the form of biosphere that I envisaged consists of a loose collection or swarm of objects traveling on independent orbits around the star. Science, July 22, 1960. One argument against a Dyson sphere, swarm, or similar structure surrounding KIC 84 is that, under certain scenarios, it would be expected to absorb and then re-radiate energy and give off a detectable signature that is anomalous relative to known natural phenomena. In his original 1960 paper, Dyson suggested that this should most likely result in an increase in infrared radiation, essentially excessive waste heat. As already pointed out, there is no evidence of excessive infrared energy coming from KIC 84. However, the basic assumption may be incorrect in this case. The analyses have generally assumed that the aliens would be human-like in terms of their fundamental technologies and use human-like techniques to build their Dyson structures with materials similar to those we might use, metals, ceramics, and so forth, that would be predicted to give off anomalous infrared emissions. However, alien technologies might be of such an advanced nature or efficiency that excessive waste heat is not given off, possibly excess heat would be collected and utilized. Depending on the nature of the Dyson swarm around a star, it could theoretically give exactly the pattern of dips in brightness observed with KIC 84. The problem relative to testing the alien megastructure idea is that we have virtually no way of falsifying such a hypothesis, since a theoretical model of an alien megastructure can be created which will fit any number of parameters and datasets. One concept I find particularly interesting, however, is that the long-term dimming of KIC 84 may be due to the progressive construction of a Dyson swarm around the star that has obscured ever more light overall from our view. Did our instruments just happen to image this star during the building phase of a Dyson sphere? Of course, given that KIC 84 is over 1,000 light-years away, the Dyson swarm may be long complete. Another form of star lifting is the actual mining of a star for metals or other elements. As suggested by Edward Heindel, Furtwangen University in Germany, perhaps aliens are superheating a portion of the star to create a jet that literally lifts material off the star and places it in orbit around the star where it can cool down, with the result that from our perspective, the star will appear to dim periodically and also perhaps over the long term. Or perhaps, as Clement Vidal, Free University of Brussels, has hypothesized, there are stellivore, feeding on stars, civilizations that utilize a small black hole or some other means to extract energy from a star. Could this be the explanation for the unusual behavior of KIC 84? Overall, I agree with astronomer Jason T. Wright and his co-authors, Pennsylvania State University, who have written, "We have in KIC 84 a system with all of the hallmarks of a Dyson swarm." Given this object's qualitative uniqueness, given that even contrived natural explanations appear inadequate, and given predictions that Kepler would be able to detect large alien megastructures via anomalies like these, we feel it is the most promising stellar SETI, search for extraterrestrial intelligence, target discovered to date. Wright et al. 2015, the G-search for extraterrestrial civilizations with large energy supplies. 4. The signatures and information content of transiting megastructures. Taking up this call, various astronomers have searched for radio signals suggestive of alien technology associated with KIC 84. Thus far, they have come up short. However, the truth is that we do not really know what to look for. Alien technology may be unexpectedly different. There is no guarantee aliens would use communications and engineering technologies similar to ours. Given the data from KIC 84, I believe we have strong indications that we may have located an advanced alien civilization. I doubt that they are aware of us. 1,200 to 1,500 years ago, the time it takes for electromagnetic radiation to travel from our solar system to KIC 84, we were in the depths of the European Dark Ages. 1,000 years from now, will we be building a Dyson swarm around the Sun?